Hello, my name is Yogendra Kumar, and I'm going to we are going to start today number system chapter, which has weightage of 8 marks in CBSE. Okay, in your school exam, it has weightage of 8 marks. But apart from that, it is very important chapter for understanding the because we are going to deal with the different kind of numbers further, so it is important in that way, like we are like from now on, like we are going to deal with so many kind of numbers, so that's what we are going to learn in this chapter. And weightage is there, but apart from that, okay, it is like just starting the maths. Okay, so we need to do use these all numbers which we are going to study in the upcoming chapters. Okay, these all numbers we will be using, so that's why it is very important chapter. Okay, my name is, by the way, okay, brief about me. Okay, my name is Yogendra Kumar, and I have total 8 years of teaching experience now. Okay, and then I'm a BTech graduate. Okay, in 2010 I cleared my BTech exam, course I completed. Okay, so after that I'm into teaching. Okay, so let's start, guys. Okay, like let's do the uh, topic related things further. Okay, so it is lecture number 1 for the number system chapter. Okay, so what we are going to see in this chapter, we are going to cover these all topics: number line. What is a number line? Okay, how do we show the number line? Okay, that is what we are going to talk about. Like number line, I hope you know, many of you, that it is what this number here is 0, and right side of the number line is what positive numbers are there here, positive numbers, and this side, these are negative numbers. Okay, left side are what, negative numbers. So this way we are trying to keep the standard. Okay, that this is what we are going to follow. Okay, or like everyone will follow. Okay, like this we will be studying number line. Okay, it is not different for person to person. Like they can't keep, okay, like other side numbers. Okay, like different numbers and all, like you can't change this. Okay, this is what we need to remember, number line. So if you say here, this is what minus infinite and this is what plus infinite. Okay, like this here, negative infinity and positive infinity. What is the meaning of that? Okay, like very big number here this side, and very negative very big number. Okay, like that there. So what we are going to see next, okay, rational numbers, irrational numbers, then their decimal, like okay, by the way, what are real numbers actually? Like I think we can start right away here. What are real numbers? We have whatever numbers we talk about. Okay, what all numbers we study, okay, in maths. Okay, and so far whatever number you studied, those all are real numbers. Okay, there are imaginary numbers also we talk about. Okay, but that is later on. As of now, whatever numbers you are dealing with, okay, those are all real numbers. Okay, so as of now you can assume that all are real numbers only, whatever we are studying. Imaginary number comes in one of the chapter, complex number, which is there in 11th grade. So as of now you don't need to worry about imaginary numbers. All are real numbers. Whatever number you are able to write as of now, whatever number you are dealing with in maths, okay, those all are real numbers for us. Okay, so these real numbers could be rational, which are of this form, integers, whole numbers, natural numbers, or irrational, which are like, which looks like difficult to handle. Okay, like which are like kind of little bit complicated than these rational numbers. So we can say irrational numbers are like these kind of weird numbers. Okay, you can say, right? Okay, that's what it is. So pi, e, root 2, these are irrational numbers for us. We are going to talk about these more, okay, later on, but as of now these are what you can remember. We will discuss about them in detail, okay, later on, but let's come to the topic, okay, which is what we have next. Okay, so as I told you about the number line, right? Already, number line is a pictorial representation. You can read about it, okay, like this. Okay, like I think you can understand this line meaning. Okay, the definition is written. Definition is not so important, but what is the basic idea? Okay, that is what important for us. You can add here minus infinity to positive infinity here, right? Like this here, very big positive number, very big very like negative very big number. Okay, like we can say, okay, this is called as right side of number line, and this is what left side. Zero is a point where we decide right or left. Okay, so zero is what very important, and then about that only we are going to say it, left side. So what are the numbers here? Positive, this side positive numbers, as I told you before, and this side negative numbers. Okay, negative numbers are there. So important notes on a number line, the number on the left is always less than the, yes, this is very very important point. A number on the left means the number which is here and here, which is lesser. On the left, on the left is what? Minus 10, so that is less. So we say always we are going from this side. We read, actually, by the way, we will be reading the numbers from this side. Okay, like this, left to right. Okay, we can read from this side also, but what it is, increasing order is like this. Okay, from left to right it increases. So this is what increasing order, left to right we will go. A number on the right is always greater, right? I think it makes sense. Like you might be understanding this, right? Okay, very good. Chalo, next I think we can move on to next. What, this is very very important, guys. Okay, what we need to learn now? Rational numbers. What are rational numbers actually? So if any number which can be written in p by q form, any number which can be represented in p by q form is called as rational numbers. There are few conditions which we need to remember, right? Q should not be zero. Denominator of any number should not be zero. Otherwise, it is not like it is not defined. Actually, we cannot divide a number by zero. It's impossible to divide a number by zero, right? So that's why we say it is not defined if it is zero. If you say 5 by 0 is what? It is not defined, right? It is not defined. Okay. Also, we can say that any fraction fits under the category of rational numbers where denominator and numerator are integers and denominator is not equal to 0, right? So if I say here, this is what, okay, not a rational number. But if I say is 1.1 a rational number? Yes, it is rational. Why? Because 1.1 can be written as 1. Okay, what is there in the denominator of every number? What is there in the denominator of every number? We have in the denominator, we have the this one. So we have 1. So now it can be removed off. Okay, like this point can go. So it can be written as finally 11 by 10. So is the numerator integer? Yes. Is the denominator integer? Yes. Is the denominator equal to, not equal to 0? Yes. Right. Is it fulfilling all the things here which we want to talk about? Right. One more last point, when rational number. Okay. Okay. One more point is what very important here. In p by q form, both should be co-prime numbers. Okay. These two should be co-prime numbers. What is the meaning of that now? Co-prime numbers means we say that there is no common factor. Co-prime numbers means what? There is no common factor. Okay, this is also important point. I know it is not mentioned, but you can write. Okay, there should be no common factor. When rational number is divided, the resultant will be a decimal form, which may be either terminating or repeating decimal. Okay, we will come to this point again. I know it might not be making much sense here, but no problem. I'm going to take the example, okay, for to explain this when we will see the decimal expansion, right? So this is what it is. I hope you are getting the idea. Rational numbers are what? Those numbers which can be represented in p by q form. Now if you say is 5 a rational number? Yes, 5 is a rational number because 5 divided by 1. P is integer, Q is integer. Are they co-prime number? Yes. Is Q not equal to 0? Yes, right. Q should not be equal to 0, right? So that's what we need to remember. Perfect. Okay, so let's move on to the next slide. Okay, I hope it is clear. Okay, now what are irrational numbers? So just opposite. Okay, numbers which cannot be written in P by Q form. Numbers which cannot be represented which cannot be represented into the p by q form. Those are what? Irrational numbers, like pi is there, root 2 is there, root 3 is there, root 5 is there, right? These are what? Irrational numbers. Okay, these are what? Irrational numbers for us. Is root 8 irrational number? Yes. 2 root 2. So this is irrational number. Is root 4 irrational number? No. Irrational. But this is 2. So which is what? Rational. If it is a perfect square inside the root, obviously it can be represented in p by q form. But this number cannot be represented in the p by q form. Okay, an irrational number cannot be written as simple fraction, but can be represented with a decimal form, right? It has endless non-repeating digit, okay, after the decimal point. Okay, now what is the meaning of this thing? Okay, see here also you can understand, like pi is like 3.14159, okay, like that. It continues. It is like never ending, right? That is what irrational form, which is never ending and never repeating. It is not repeating also. It is 14159, and then it will be like, we don't know, like we can do that, but it will be like keep on giving the numbers like that. But here 1.5 is 3 by 2. It is terminating, so it is rational form, but it is here, it is irrational form. I hope it makes sense, right? When we will see the decimal form of the numbers, okay, it is like we are going to understand that further, right? Let me make this clear first. Okay, right, I think this is clear to everyone. Okay, let's do further now. I'll take the examples also next. Okay, but this is what. Okay, now, okay, yeah, let's see the question. Okay, now, identify each of the following as irrational or rational. So 3 by 4 3 by 4, is it p by q form? Yes, p and q both are integers. Yes, correct. Q is not equals to 0. Yes. Okay. It is satisfying, right? What are the three conditions we say? First condition, second condition, and one more condition I would add. Okay, which is what? P and Q are co-prime. Yes. Okay. All three, right? All three are checked. Okay, so we can say, right? Yes, it is. It is what? A rational number. It is what? Rational. It is fulfilling the definition to be rational, right? These are the points. Now, is this one 90 divided by 12007? Now both p and q are integer. Yes. Are they co-prime? Yes, they looks like co-prime. Okay, if we divide, okay, yeah, they are going to give us, okay, like co-prime form. Yes, and q is not equal to 0. Yes, so it is rational. 12 12 divided by 1. 12 is like 12 divided by 1. What is there in the denominator? It is 1. So it is rational. Yes. Okay, what about root 5? Root 5 cannot be bring into, is not equivalent to p by q form. So not irrational. Means it is what? Irrational. By the way, you need to remember one more point. Okay, you can understand this here. What do we say? All the real numbers. All the real numbers. Let me write down this point because it is very, very important. Which color? Yes. Okay. As I don't have the space, okay, let me write down here. Very, very important point. All real numbers are either rational or irrational. There is no third form. Okay, there is no third thing. Either all real numbers. Okay, let me write down like this. Real numbers, they are rational or irrational. Okay, that's what the meaning, right? I either they are rational or irrational. That's all, right? They can be further divided, right? Rational can be written as what? Rational numbers can be written as integers. Okay, then whole numbers and all. Okay, right? I think you can understand from here. Okay, this is what perfect here. Real numbers. Okay, real numbers are rational or irrational. Irrational are these forms. Okay, this form is what, by the way, it is terminating, but I'm coming to that also, right? Okay, we can add here one more thing. 0.14 14 14 and so on. This is rational. That is not added here, so I'm adding this. It is called as non-terminating recurring form here. Okay, this is the terminating. Okay, so this should not be there. Okay, oh wait, let me correct here. This is not given correctly here, so let me correct here this one. Eraser I need here. Yes, so I'm correcting it here. This should be, the correct format should be, let me use black color only here. 30 300 300 then, and that's all. It is continuing. 3 zeros were there, 4 zeros are coming, and then all it's continuing, which is what here, what is the exact thing here? It is non-terminating non-recurring. Non-recurring. Now, how do we bring this form to P by Q form? We are going to see that next. We will see that. Okay, how do we bring the decimal form to uh, decimal form to this decimal form to P by Q form? We will see that. We are going to learn that. Okay, but here this is what non-terminating and non-recurring form. It cannot be bring to P by Q form. That's why it is what, irrational, right? But here we are saying this form is what, this 0.141414. This is what non-terminating recurring. So what we say here means we can write it in the P by Q form, because every rational number can be represented in the P by Q form. So we should be able to bring it into the P by Q form, right? So we are going to see that. Okay, how do we do that, right? Okay, so these are all the solutions provided here. Okay, okay, I think let me explain you here. Okay, for this particular form, okay, what, okay, they didn't discuss here. Okay, let me write down how 0.141414 is, how this is rational number. How this is rational number. So what do we do actually? Like, I should be able to write down, if it is, write P by Q form. Okay, so what do we do here? Let's say this number is what, some x number. So 0.141414. Now here, what I'm going to do here, can I multiply 100. I'm going to multiply 100 to the number 100. X is equals to 100 times of 0.141414. Now what does it what it changes to? Like, what is the form it is we are going to get? We are going to get 100x is equals to two digits will come to this side, because when we are multiplying to by 100, that is what the changes it is going to come here. 141414. Now can I write this above number x down here? Okay, I'm writing this number only, this x here as it is. X was what? 141414 and so on. So now I'm dividing it here. So what it becomes here, from the unit place it will start becoming 0, and then 0.14, and that's what the thing we wanted, right? That is what 99x here, and this is what after decimal point we have 000 here, right? So what does it that mean? Means we don't need to write down 00. We know if point ke baad mein there is no value, there is no meaning of writing zeros after point, right? So what do we get here? We get that x is nothing but 14 divided by 99. So this is what our p by q form. This is what we got our p by q form. So now can we say confidently that it is what? Rational number. A rational number it is. It is our rational number, right? Okay, now decimal numbers, decimal representation of a real number. Okay, so suppose 1 by 2 is there, 0.5. We know that we can do long division. This is what called as long division, and we can get the, when remainder is 0, these are the forms. When remainder is not 0, it will be continuing like this. But what happens to p by q forms? Like what we are doing exactly here, it is like 5 divided by 11. 5 divided by 11. So we write here 0.000, and now 11 we need to read into. I hope this is simple, right? We can do that points. We need to add 0, so 0.4 and 44 here like this. So what is the form we are going to get? 0.45, 45, and so on. So can you see this? It is what? Rational number. And what is the form here? We have rational number. What is the form of rational number we are getting here? What kind of form we get? If either it will be terminating, rational number will have terminating decimal form, or it can be non-terminating but repeating or recurring repeating form, right? So what would, let me say it again because it is important to understand here. Rational number will have either terminating decimal form or non-terminating. If it is non-terminating form, then it has to be repeating form. Okay, it has to be recurring. It has to be recurring. Otherwise, it is not possible. If it is like non-terminating and non-recurring, then that is what we will say. We will say that is what our, what form is that? Irrational form. We need to say that is our irrational form. If it is terminating, if it is terminating decimal form, so we are we can make our answer, it is what? Rational form directly we can say. But if it is non-terminating, and non-terminating decimal form may be rational or maybe irrational, depending on it is repeating or it is non-repeating. If it is non-repeating, then it is irrational, or if it is repeating, then it is rational, right? So but if now they can make so many questions out of it. Okay, is the rational form always terminating? No, it may be terminating or non-terminating. Is the irrational form terminating? No, irrational form cannot be terminating decimal form. Okay, it can never be terminating decimal form. Yes, so I think these points can uh, you can understand easily. We can get decimal representation of rational number by long division method. When we divide p by q using long division method, either the remainder becomes 0 or remainder never becomes 0. We get repeating remainders. Yes, okay, let's move on to next slide. So now they are saying express the following rational numbers as decimal form. I hope it is pretty easy, right? 3 we can divide. Now there are two methods we can have here. One is what? Long division method. Another one is what? Without long division also. For this especially, okay, for this number, we have two methods. Okay, so first method, the long division method, we can understand here. Long division method will be, let me show you this here. 3, then we divide by 4, point we write, and then 0. So 4, how many times it will go? 7, 28, then 2 is there, point is already there, so 0. Now 4 fives, so it is what? 0.75, right? Now I said, okay, we can do this without long division also. How can we do that? Okay, 3 divided by 2 into 2. Now there are two 2's. Can I do here? Can I multiply by 1 5 here, 1 5 down? Because if in a number we multiply by the same number up and down, it is indirectly like 1 we are multiplying. So it doesn't change the value, right? So that's what I'm doing here. But what is the benefit I'm getting out of it? Okay, this 2 and this 5 will give me 10. This 2 and this 5 will give me another 10. So basically I'll get here 3 into 5 into 5 divided by 10 into 10, which is nothing but 25 into 3, 75 divided by 100, and which can be easily written as 0.75. Because this thing, I think we can avoid the long division to do this, and we can write down easily. So that's what, there are two methods. Okay, method number 1, method number 2. So we will be using this now, this faster method to do it. Okay, like long division we will avoid. Same thing can be done, I believe, like this we can do easily. 5 divided by 2 into 2 into 2. So how many 5s I need to multiply here? How many 5s will be required here? 1 5 here, another 5, another 5, another 3 2s are there, 3 more 5. So 5 into 5 into 5, this will give you 625 divided by how many tens? 3 tens, so which is 1000. So 0.625 is the answer. Perfect. Similarly, we can do for this also. 9 divided by 16 means 2 into 2 into 2 into 2, which will make it what? Again, we need to multiply 9 into 4 fives. So 625 divided by 10,000. Now we can multiply up by 9. Okay, here. So it is 10,000. Now 5 here, then 9 to the 18, and 2 here, then 9 for the. Okay, we are getting 56. So we got answer 0.5625, right? Now, okay, we have this number, which is what? 7 by 25. So we can write 7 by 5 into 5. Now, again, I can make the tens here, okay, by multiplying 2. How many 2's? 2 2's. So it is 428 divided by how many tens? 2 tens, so 0.28 is the answer. Now here, what about this number? Can I avoid, it is rational number again, but can I avoid here long division? No, we cannot avoid. We need to do long division here. only for, not for every number we can do the above method, because in the above questions we were able to generate what, tens down there, right? We were able to write, make it into the 10 multiplication form, means 1000, 100, or 10,000, like that. I was able to generate, so that's why we did that. But here we need to do 47 ko we need to do 99, like this only, means point I need to write and 0 here. So how many times it will go? 4 times, right? 4 times here. So what we'll write? 6 here, 396. So 4 here, then 16, so 7, right? So again 0 here, 7 times it can go, right? Now 7. Okay, so we will get 693. Then we can write again what it will be, 7 here, and then here 4, then again 0 here. How many times? 4 here, 7 here, 4 here, 7 here. It will keep on repeating. Okay, we will not get terminating. We will not get terminating decimal form here. 0.474747. This is what it is. So this is what, okay, we can understand that it is what, rational number. So we are getting non-terminating decimal form here, but it is repeating. Above we were getting terminating decimal forms. Why we were getting terminating decimal forms? So we can understand one more thing from here, that if denominator of a number is of the form like 2 power m or 5 power n, means fives are there in the denominator only, or twos are there in the denominator only, or we have 2 and 5 only, then it will be terminating decimal form. Otherwise it will be non-terminating decimal form. And if it is rational number, obviously it has to be repeating. I think it is making sense, right? We have the solutions on the next page for all these, right? So this is what it is. Decimal expansion, we have terminating, means it is a rational number. Non-terminating could be repeating or non-repeating. So it will be rational if it is repeating. I made it clear already. This one, non-repeating, it is irrational. That's all. This is what we need to remember. And I showed you without long division also, we can avoid the long division to do this all. But not for this fifth one. We can avoid long division here. We can avoid long division here, but not in the down one. Yeah, right. Last question. In the last question, we will have to do the long division. Okay, now next topic is what we need to do the plotting of the numbers. Okay, we need to do the plotting of the numbers. My bad. Okay, yes, yeah, plotting of real numbers on the number line. We need to understand how do we plot the real numbers on the number line. So how do we do here, right? I believe like this is pretty easy. Okay, so what we do here, if any decimal form is there, okay, I'll be requiring space here. Okay, let me make it here, like they have shown here. Okay, that 0 is here. Now 1/2 decimal form is what? 0.5. 0.5 will be obviously between 0 and 1, so we can plot it here, right? Now if suppose they say not 0.5, plot 0.05, right? We need to plot 0.05. So now what we'll do, okay, not this, we want to plot 0.05. So we know that it is going to be between 0 and, okay, let me write here, plotting 0.05. So we know that it is going to be in between 0 and 1. Now, it is not 0.5. If it was 0.5, exactly in the middle we will get. But it is what? 0.2 decimal point is there. So let's break down this part, okay, between 0 and 1 into how many? 10 equal places, okay? 10 parts we want to break them into, okay? So we are doing here like this, here 1, 2, 3, 4, 5, right? Like that. 1, 2, 3, 4, 5 here, right? Like this. So this is what 0.5, this is what 0.1, this is what 0.2, this is what point. You can make it bigger. I was not having space, so that's why I made it little small, okay? But you can make it bigger. Now what we do here, okay, let me show you here. We zoom into this. It is kind of zooming into, right? We are kind of zooming into this thing. So this is what 0 here, and this is what 1 I got here. So in between, 0.5 is there. Here, 0.1, 0.2, 0.3, 0.4, and 0.5. 0.1, 0.2, 0.3, 0.4. And now this side also points will be there, right? We can say, now we want to plot 0.05. So we need to zoom into 0 and 0.1. So we need to kind of zoom into these two here. We will write it here. 0, my bad, 0 it is, not 0 point something. Okay, let me make it 0.0. Yes. And then here 0.1. So again breaking down here, okay, 0.01, 0.02, and 0.05 will be exactly in between, right? So that's all. That's what we got. Correct places. So between 0 and 0.1, we have this. So it is kind of zooming into the thing. Okay. If suppose they're asking 0.0059, now we need to do it further, right? We need to go into deep into this, right? That's what plotting of the real numbers on the number line. You get the decimal form of it, and then look at the right place of the number. That's how we are going to do. Plotting of irrational numbers we are going to learn next class, but as of now, plotting of real numbers is what, like this. We can talk about it more later on, okay, when we will be doing plotting of irrational numbers, but this is what it is, because we are going to see it further, okay. Now this okay, let's do this practice question. Determine whether the given numbers are rational or irrational. So this number is what? Clearly it is what? Rational. Why? Because it is terminating decimal form. This is also rational. This is a, my bad, it is what? Rational again. Let me use the symbol R only for rational numbers, and for irrational I'll be using IR. So it is rational. This is rational. This is what? Clearly irrational, because we will not get the decimal form. It will be something like point, what will be the form? 0.173, then 21, and so on, like that. Okay, it will be non-terminating, non-repeating, right? Express the following numbers in the decimal form. Can we express it? Can we do it without long division? No, it cannot be done without long division. So 1, okay, let me do it. So we can do it by the help of 1 here, then 999. Now how many zeros we need to put? Okay, point, then 0, then one more 0, 0, then one more 0. So it will start like this. Okay, how many times it will go? 1. So 999. Now here what we got? 1. Now again, what I need to do here? One more 0, 1 0, right? What I can do? Are you getting it? We need to add here zeros, and then again, like we need to make it right in this form. Then okay, 1 0 to because of point, then 2 more zeros, then again it will go one time, right, like this. So again 1, so 2 zeros again, like this one. So this is what going to give us point 001 001 001 and non-terminating recurring form, non-terminating recurring form. Now what about 26 divided by 45? 26 divided by 45. Now we can divide again, long division we can do. I hope solution is there, right? You can do again. We have done the questions again like long division. Can we do it without long division? No, because here again, what are the factors of the denominator? Let me show you those. You might ask, okay, can we, because here 5 will be there, right? So can we do without long division? No. Why? Because it is what? 3 into 3 into 5. This is what it is, right? 45. So 5 is there, it is good thing, right? 5 is there. Basically what we can do, we can simplify if you want by multiplying 2 up and down. If you want, okay, 2 up and down we can multiply, but we cannot reduce it much. We cannot avoid here long division, I mean to say. 52 divided by what here? 9 into 10. So if you want, what you can do, 5.2 divided by 9 and then divide 52 by 9. That's what, like, we can simplify it little bit by the above method, which I think I showed you this. Okay, 5.2 to 9. So point I need to put now, 9 fives are 45. What is the remainder here? 7. Then point here. So what we need to write here? 0. Now 9 sevens are 63, again sevens are, so 7 7 like this. So 0.5777, like this it will be repeating, right? So these are the answers we have here. Exactly, exact answers, right? I hope you got the points. I hope it is clear, right? Both these solutions and all, it makes sense, I think. That's what we have. So I hope you enjoyed the session. Okay, we will continue next class. Okay, next in the lecture number 2 we will be discussing about it more. If any point is left out, we can talk about it. Okay, so stay tuned to the lectures. Okay, let's discuss next class how do we plot irrational numbers. We didn't discuss that. As of now we have seen plotting of rational numbers only, so we need to learn that, right? I hope it is clear, right? Every point here, it is clear to you. So let's end the class here. Okay, thank you very much.